January 29th, 1941. The Coronado Hotel, San Diego. Charles Sorensen, Ford Motor Company's legendary production chief, stood over scattered hotel notepaper in the dim light of his room, sketching furiously with a pencil. Outside his window, the Pacific waves crashed against the shore, but inside, a revolution was taking shape on those hastily drawn lines. Earlier that day, the 60-year-old Danish immigrant had toured Consolidated Aircraft's B-24 Liberator production facility and witnessed something that shocked him to his core. America's most advanced heavy bomber was being assembled outdoors under the California sun, piece by painstaking piece, like a custom suit tailored by hand. Each aircraft took weeks to complete. Workers crawled over skeletal frames exposed to the elements, precision parts warping in the heat, while the nation's military leaders demanded thousands of these four-engine giants to fight a war that hadn't yet begun, but was already inevitable. As Sorensen's pencil moved across the hotel paper, he wasn't just drawing factory blueprints. He was designing the impossible. A mile-long manufacturing cathedral that would transform 450,000 individual parts and 360,000 rivets into a complete heavy bomber every single hour. The aviation experts would call it fantasy. German intelligence would struggle to believe the reports. But in that cramped hotel room, surrounded by the detritus of his calculations, Cast-Iron Charlie was about to unleash American industrial might on a scale that would redefine warfare itself. And that was the moment the entire war shifted, though almost no one realized it at the time. This video examines published sources for educational purposes. Interpretations are attributed. No claims are asserted as fact without citation. Before we uncover today's secret from the pages of military history, if you enjoy exploring the hidden stories, decisive battles, and overlooked moments that shaped our world, please take a moment to like this video and subscribe for more untold wartime histories. And let me know in the comments where you're watching from. I'm always amazed how these memories of the past connect us across so many corners of the world. The mathematics of impossibility were staring Charles Sorensen in the face that January morning in 1941. According to historical records maintained by the Ford Motor Company archives, the B-24 Liberator represented everything that conventional manufacturing wisdom said could never be mass-produced. This wasn't an automobile with its 15,000 components weighing 3,000 pounds. The Liberator contained 450,000 individual parts, required 360,000 rivets in 550 different sizes, and tipped the scales at 18 tons when empty. Historians note that each bomber measured 67 feet in length and required precision assembly that aviation manufacturers had perfected through decades of careful, craft-based construction methods. Yet Sorensen possessed something his aviation industry critics lacked. 4 decades of experience revolutionizing American manufacturing, earned through blood, sweat, and the relentless pursuit of production efficiency that had transformed Ford Motor Company into an industrial empire. Born in Denmark and immigrated to America at age 4, according to Ford Company biographies, Sorensen had started as a humble pattern maker before becoming the architect of the modern assembly line. His colleagues knew him by his nickname, Cast-Iron Charlie, a testament to both his foundry expertise and his iron-willed determination to solve manufacturing challenges that lesser minds deemed unsolvable. The tour of Consolidated Aircraft's San Diego facility that January day had revealed something that violated every principle Sorensen held sacred about efficient production. Records from the inspection indicate that America's most sophisticated heavy bomber was being assembled using methods that belonged in the previous century. Workers labored under the open California sky, exposed to temperature variations that warped precision machine components out of specification. Parts were fitted by hand, adjusted individually, and assembled through processes that more closely resembled custom craftsmanship than industrial manufacturing. Dutch Kindleberger, president of North American Aviation, captured the aviation industry's sentiment perfectly when he sneered, according to contemporary press accounts, You can't expect a blacksmith to make a watch overnight. The established aircraft manufacturers viewed Ford's ambitions with a mixture of amusement and condescension. These aviation experts had spent decades perfecting their craft-based approach to building aircraft. Each plane represented hundreds of hours of skilled labor, careful fitting, and individual attention to detail. The idea that automotive mass production techniques could be applied to such sophisticated machinery struck them as naive at best, catastrophic at worst. But Sorensen saw something different in that California sunlight. According to his later recollections preserved in Ford archives, the scene reminded him of Ford's earliest days, before the revolutionary Highland Park plant, before the moving assembly line that had transformed manufacturing forever. He was witnessing aircraft production in its pre-industrial phase, much like automobile manufacturing had existed before Henry Ford and his team had reimagined what was possible. The scope of the challenge became clear as Sorensen's engineering teams began their analysis. For the next 6 months, according to Ford production records, he orchestrated an unprecedented industrial intelligence operation. 70-man teams of engineers and draftsmen shuttled back and forth on 2,300-mile journeys between Ford headquarters in Dearborn and Consolidated's works in San Diego. Their mission was to completely understand every aspect of B-24 design, engineering, and component integration. What they discovered was both encouraging and terrifying. The existing engineering drawings for the Liberator were, according to the Ford team's analysis, essentially illes for us mass production purposes. The blueprints were incomplete, filled with discrepancies, and marked with unfamiliar symbols that made sense only to the specific craftsmen who had created them. Critical manufacturing knowledge existed not on paper, but in the memories of plant foremen who had learned their techniques through years of hands-on experience. Sorensen's response demonstrated the methodical brilliance that had made him Ford's production genius. He ordered 2 complete B-24 Liberators flown to Dearborn, where they were systematically dismantled piece by piece. Every component was measured, catalogued, and analysed. A 1,000-member tool design group, according to Ford records, worked around the clock 7 days a week for almost a year to create 3-dimensional schematics of the plane's 30,000 separate components. The scale of this reverse engineering effort defied comprehension. The Ford team generated 5 million square feet of blueprints in the process of understanding the Liberator's construction. Every rivet, every structural member, every electrical connection had to be documented with the precision necessary for mass production. Where Consolidated's craftsmen relied on experience and intuition, Ford's system would depend on mathematical precision and standardized procedures. Sorensen's genius lay in his ability to see patterns where others saw only complexity. He methodically broke the complex bomber into 11 major assemblies, then further divided these into 69 sub-assemblies. This hierarchical approach allowed him to apply Ford's proven mass production techniques to each component while maintaining the overall integrity of the final product. According to the production plans preserved in company archives, each plane would consist of 488,193 individual parts, yet the system was designed to turn out finished bombers at the still astonishing rate of 1 per hour. The plant that would house this industrial miracle was itself a marvel of engineering ambition. Carved and designed by renowned architect Albert built on farmland near Ypsilanti, Michigan, the Willow Run facility would eventually encompass 4,734,617 square feet of manufacturing space. The main assembly line stretched over 1 mile in length, making it what many historians consider the largest factory under one roof anywhere in the world at that time. The factory's design incorporated innovations that reflected both Ford's manufacturing philosophy and the unique requirements of aircraft production. 4 large turntables were positioned 2/3 of the way along the assembly lines, allowing the B-24 production lines to make a 90-degree turn before continuing to final assembly. This seemingly minor detail solved a crucial problem, according to planning documents. The turn kept the entire factory within Washtenaw County boundaries, providing significant post-war tax benefits while maintaining the linear flow essential for efficient mass production. Construction of this industrial cathedral began in earnest in 1940, but completion wouldn't come until 1942. The intervening months saw Sorensen's teams working frantically to solve thousands of engineering challenges that had never been attempted before. Custom machine tools had to be designed and built. Fixtures weighing thousands of pounds and standing 60 feet tall were created to hold aircraft components during assembly. Every aspect of the traditional aircraft manufacturing process had to be reimagined for mass production. The skeptics weren't entirely wrong to doubt Ford's ambitious timeline. Early production at Willow Run faced significant challenges that seemed to validate the aviation industry's pessimism. Only 56 airplanes were completed in all of 1942, according to production records. Critics began calling the facility Will It Run, rather than Willow Run, suggesting that Ford's automotive expertise couldn't translate to the complexities of aircraft manufacturing. The problems were real and substantial. Government design changes constantly disrupted Ford's carefully planned production sequences. Each modification required expensive and time-consuming updates to the assembly line, exactly the kind of disruption that mass production methods were designed to avoid. Where automotive manufacturing could standardize on a single design for an entire model year, aircraft production during wartime meant constant evolution to incorporate lessons learned in combat and advances in technology. Senator Harry S. Truman's visits to the plant in April 1942 and again in February 1943 brought unwelcome scrutiny from the highest levels of government. Truman, heading a presidential committee charged with eliminating wartime production waste, was unimpressed by explanations about design changes and startup challenges. According to contemporary accounts, he wanted finished bombers, not excuses. A congressional committee's 1943 report was particularly harsh, criticizing Ford for creating a production line that too closely resembled an automobile assembly line, despite the warning of many experienced aircraftmen. Yet even as critics questioned Ford's approach, something remarkable was happening within the vast halls of Willow Run. The production numbers began climbing steadily throughout 1943. Ford built in January 37 planes, 70 in February, 96 in March, and 146 in April. The system was learning, adapting, and gradually overcoming the challenges that had seemed insurmountable just months earlier. The workforce assembling these mechanical marvels represented a revolution in American manufacturing that extended far beyond production techniques. By necessity, Willow Run became a model of diversity that wouldn't be matched in many industries for decades. As able-bodied men were drafted or volunteered for military service, Ford began hiring women on an unprecedented scale. According to employment records, women made up 15% of the Willow Run workforce by May 1942, eventually growing to nearly half of the facility's 42,500 employees at peak production. More remarkably, these women earned the same wages as their male counterparts, 85 cents per hour according to payroll records from the period. This equal pay policy was revolutionary for its time and demonstrated that when necessity demanded it, traditional barriers could be overcome. Women filled not just assembly line positions, but leadership roles, and even served as test pilots for completed aircraft. The famous Rosie the Riveter wasn't just a propaganda symbol at Willow Run. Her real name was Rose Will Monroe, and she represented thousands of women who proved their capability in highly technical and demanding manufacturing roles. The transformation accelerating within Willow Run's cavernous halls, 1943, represented more than statistical during improvement. According to Ford production analysts studying the period, each month brought systematic solutions to problems that had plagued the startup phase. The company's engineering teams had developed specialized techniques for handling the Liberator's most challenging components, including the massive center wing section that formed the structural heart of each aircraft. This center wing assembly showcased Ford's revolutionary approach to aircraft manufacturing. Traditional aviation companies built wings through labor-intensive processes that required dozens of skilled craftsmen working for days to complete a single unit. Ford's engineers redesigned the entire procedure around precision tooling and standardized assembly sequences. According to technical reports preserved in company archives, overhead cranes now hoisted completed wing sections onto the final assembly line with mechanical precision, eliminating the manual lifting and positioning that had characterized conventional aircraft production. The breakthrough came through Ford's systematic deconstruction of complex manufacturing processes into manageable, repeatable steps. Where aviation industry veterans saw irreducible complexity, Sorensen's teams identified opportunities for standardization and mechanization. Custom-designed fixtures, some standing 60 feet tall according to engineering specifications, held aircraft components with thousandths of an inch tolerances, while workers performed their assigned tasks. The marriage of precision engineering and mass production principles was creating something unprecedented in manufacturing history. By late 1943, the production statistics began reflecting this industrial transformation. Employment records indicate that Willow Run's workforce had grown to over 70,000 individuals during the facility's operational peak, with workers flowing through the plant in carefully orchestrated shifts that maintained continuous production. The diversity of this workforce continued expanding beyond gender equality to include African Americans and other minorities who found opportunities in the booming war production economy that had been largely unavailable in peacetime manufacturing. The technical innovations emerging from Willow Run extended far beyond simple assembly line concepts. Ford's tool design group had created what amounted to a manufacturing revolution, developing 1,600 specialized machine tools and 11,000 custom fixtures, according to production records. These weren't merely scaled-up versions of automotive equipment, but entirely new categories of manufacturing machinery designed specifically for aircraft production. Some fixtures were engineered to stamp, mill, drill, broach, and grind parts with precision that exceeded even Ford's legendary automotive standards. The psychological impact of these achievements began resonating throughout American industrial circles, and more importantly, in the intelligence assessments of America's enemies overseas. German industrial analysts studying Allied production capabilities through various intelligence channels found themselves confronting reports that challenged fundamental assumptions about manufacturing limitations. Traditional European aircraft production methods, perfected through decades of craft-based development, simply had no framework for understanding what Ford was accomplishing at Willow Run. The November 3rd, 1943 celebration marking Willow Run's 1,000th completed B-24 Liberator represented a watershed moment that silenced many critics and validated Sorensen's revolutionary vision. According to contemporary news accounts, employees gathered to witness this milestone achievement, understanding that they had participated in something historically significant. The aircraft rolling off the production line that day wasn't just another bomber. It was proof that American industrial capacity could be applied to military production on scales that defied conventional wisdom. German intelligence services monitoring Allied production capabilities through their network of agents and sympathizers faced an increasingly difficult challenge in accurately assessing American manufacturing output. Operation Pastorius, the failed German sabotage mission launched in June 1942, had demonstrated the limitations of German intelligence operations within the United States. According to FBI records from the period, the mission's rapid failure after 2 agents defected to American authorities left German intelligence with severely limited ability to gather accurate, real-time information about facilities like Willow Run. The intelligence reports that did reach German military planners often seemed too extraordinary to be credible. Traditional German manufacturing philosophy emphasized quality over quantity, precision over speed, and craft expertise over mechanized production. The concept that Americans could produce complex military aircraft using automotive assembly line techniques contradicted decades of European aviation industry experience. German aircraft manufacturers like Messerschmitt and Focke-Wulf had achieved remarkable technical sophistication through methods that bore no resemblance to what Ford was attempting at Willow Run. Yet the evidence continued mounting throughout 1943 that something unprecedented was occurring in the Michigan countryside. Allied bombing campaigns over Europe began featuring increasing numbers of B-24 Liberators, each representing not just tactical air power, but proof of American industrial capacity. German pilots encountering these aircraft in combat could observe the consistent quality and standardized construction that characterized mass production methods, though many remained skeptical that such sophisticated machines could be manufactured at automotive speeds. The spring of 1944 brought the ultimate vindication of Sorensen's revolutionary vision. Production records from that period document achievements that surpassed even the most optimistic projections from the Willow Run planning phase. In April 1944, according to Ford Company statistics, employees working 2 9-hour shifts 6 days per week produced 453 complete aircraft in 468 hours of operation. This represented a production rate equal to one finished B-24 Liberator every 63 minutes, finally proving that Charles Sorensen's seemingly impossible one plane every hour prediction had been conservative rather than optimistic. The mechanics of this achievement revealed the full sophistication of Ford's manufacturing revolution. The mile-long assembly line moved with clockwork precision, each station contributing specific components according to carefully timed sequences. Workers had been trained not just in their individual tasks, but in understanding how their contributions fitted into the larger manufacturing symphony. Quality control procedures ensured that the speed of production never compromised the precision essential for aircraft safety and combat effectiveness. German military analysts studying intelligence reports about Willow Run's production achievements found themselves confronting industrial capabilities that challenged their understanding of manufacturing limitations. According to declassified German military documents captured after the war, intelligence assessments of Allied production capacity underwent significant revisions throughout 1943 and 1944 as evidence mounted of American industrial achievements that seemed to violate established principles of aircraft manufacturing. The psychological impact of these revelations extended beyond simple production statistics. German military planners had based strategic calculations on assumptions about Allied manufacturing capacity that were proving dramatically inadequate. If American industry could produce heavy bombers at automotive speeds, traditional concepts of war economics and resource allocation required fundamental reconsideration. The implications reach beyond tactical air power to questions about the fundamental sustainability of Germany's war effort against an opponent with seemingly unlimited industrial capacity. Peak production achievements at Willow Run during the summer of 1944 represented the culmination of 3 years of revolutionary manufacturing development. According to production records, the facility was generating completed bombers at a rate of 1 per hour around the clock, exactly as Henry Ford had promised when skeptics dismissed his company's aviation ambitions. Employment had actually decreased to 17,000 workers thanks to the manufacturing efficiencies that Ford had successfully applied to B-24 production, demonstrating that the system had achieved genuine productivity gains rather than simply throwing more labor at the challenge. The most stunning production achievement came during a concentrated burst in late April 1944, when Willow Run delivered 100 completed bombers between April 24th and April 26th, according to delivery records. This represented aircraft production at a rate that German intelligence analysts initially refused to accept as accurate. The idea that a single manufacturing facility could produce 100 sophisticated heavy bombers in 3 days contradicted everything European aviation industry experience suggested was possible. Contemporary accounts from German prisoners of war interrogated about Allied industrial capacity during this period reveal the psychological impact these achievements had on enemy morale. According to interrogation transcripts preserved in military archives, captured German aircrew members expressed disbelief when informed about Willow Run's production rates. Many insisted that American claims represented propaganda rather than actual manufacturing achievement, unable to reconcile such statistics with their understanding of aircraft production complexity. The technical specifications of the B-24 Liberator itself made Ford's manufacturing achievement even more remarkable. Each aircraft contained not just the 450,000 individual parts that Sorensen had catalogued during his reverse engineering process, but systems integration challenges that traditional aviation manufacturers addressed through time-consuming hand-fitting procedures. The Liberator's 4 Pratt & Whitney engines, each producing 1,200 horsepower, had to be precisely aligned and integrated with complex fuel, hydraulic, and electrical systems that demanded exacting tolerances. Ford's solution involved creating what amounted to a parallel manufacturing infrastructure dedicated entirely to systems integration and quality assurance. According to technical documentation from the period, each major assembly underwent rigorous testing procedures before integration into the final aircraft. Engine installations were standardized through precision tooling that eliminated the individual adjustments that characterized traditional aircraft manufacturing. Electrical systems were pre-assembled and tested as complete units before installation, ensuring reliability while maintaining production speed. The ripple effects of Willow Run's success extended throughout American war production as other manufacturers studied Ford's techniques and adapted them to their own operations. Boeing's B-17 Flying Fortress production facilities incorporated elements of Ford's assembly line approach. North American aviation applied similar principles to P-51 Mustang fighter production. The revolution that Charles Sorensen had initiated with his hotel room sketches in 1941 was transforming American military aircraft production across the entire industry. German intelligence services attempting to monitor these developments faced the additional challenge that American industrial capacity was expanding faster than traditional espionage methods could track. The recruitment and training of agents capable of accurately assessing complex manufacturing operations required months or years, while American production capabilities were evolving on timescales measured in weeks. By the time German intelligence gathered information about one facility's capabilities, those same facilities had often doubled or tripled their output through continued refinement of mass production techniques. The broader strategic implications of Willow Run's achievements were becoming apparent to military planners on both sides of the Atlantic. American bomber crews flying missions over occupied Europe represented not just tactical air power, but proof of industrial capacity that could sustain intensive combat operations indefinitely. Each B-24 shot down over German territory would be replaced by multiple aircraft from American production lines. The mathematics of attrition warfare were shifting decisively in favor of the Allies, and facilities like Willow Run were the primary reason for this transformation. The intelligence reports reaching Berlin throughout 1944 painted a picture so extraordinary that senior German military analysts initially dismissed them as Allied disinformation. According to declassified Wehrmacht intelligence assessments captured after the war, German military planners struggled to reconcile incoming data about American bomber production with their understanding of industrial capacity limitations. The report suggested that a single American facility was producing heavy aircraft at rates that exceeded the combined output of Germany's entire aviation industry. Oberst Heinrich Möller, serving as chief intelligence analyst for aircraft production at OKW headquarters, faced an increasingly impossible task, according to his post-war interrogation transcripts. Traditional German intelligence methods relied on careful observation, mathematical analysis, and conservative projections based on European manufacturing precedents. Yet the evidence streaming in from various sources about facilities like Willow Run challenged fundamental assumptions about what industrial production could achieve under wartime conditions. German agents operating within the United States faced severe limitations in gathering accurate intelligence about American war production. The failure of Operation Pastorius had demonstrated the vulnerability of German espionage networks to American counterintelligence efforts. According to FBI records from the period, remaining German agents were forced to rely primarily on open-source intelligence gathering, studying American magazines and newspapers that were then analysed in neutral countries like Portugal before being forwarded to Berlin. These indirect intelligence methods created a lag time of weeks or months between actual American achievements and German awareness of them. By the time German analysts received reports about production milestones at facilities like Willow Run, those same facilities had often achieved even more impressive capabilities. The dynamic nature of American industrial expansion meant that German strategic planning was consistently based on outdated information about Allied manufacturing capacity. The psychological impact on German military leadership became apparent in classified communications between various Wehrmacht branches during late 1944. According to captured German military correspondence, senior officers expressed growing alarm about Allied material advantages that seemed to expand faster than German forces could counter them. Each engagement with American bomber formations revealed aircraft quality and standardization that suggested mass production methods far beyond traditional European aviation industry capabilities. Reichsmarschall Hermann Göring's response to intelligence reports about American bomber production revealed the cognitive disconnect between German expectations and American achievements. According to testimony from his post-war interrogation, Göring initially refused to accept intelligence estimates suggesting that American facilities could produce heavy bombers at automotive speeds. His background in aviation industry management made such claims seem technically impossible rather than merely difficult. The broader implications of American industrial capacity were becoming apparent to German strategic planners who understood the mathematics of attrition warfare. According to German General Staff assessments preserved in captured documents, military analysts calculated that Germany would need to destroy American bomber aircraft faster than American factories could replace them to achieve any meaningful impact on Allied strategic bombing capabilities. The production rates emerging from facilities like Willow Run made this mathematical requirement increasingly impossible to achieve. German pilots returning from combat missions over occupied Europe provided first-hand testimony about Allied aircraft quality that corroborated intelligence reports about American mass production methods. According to Luftwaffe pilot debriefing transcripts, experienced German aviators noted the consistent construction quality and standardized features of American bombers that differed markedly from the individual variations characteristic of European aircraft manufacturing. Major Hans-Joachim Marseille, among Germany's most successful fighter pilots before his death in 1942, had observed in earlier combat reports that American aircraft displayed manufacturing consistency that suggested automated production methods. His assessments, preserved in Luftwaffe archives, noted that American fighters and bombers showed identical construction details across multiple aircraft, indicating production techniques that German aviation industry hadn't achieved. The technical sophistication of American aircraft reaching European skies throughout 1944 demonstrated manufacturing capabilities that challenged German understanding of industrial organization. B-24. Liberators arriving over German targets displayed precision engineering and quality control that traditional craft-based production methods struggled to achieve even with unlimited time and resources. The fact that American factories were producing such sophisticated machines at high speed suggested industrial techniques that German manufacturers hadn't developed. Dr. Ernst Heinkel, founder of Heinkel Aircraft Company and one of Germany's most experienced aviation industry leaders, provided post-war testimony about German reactions to American aircraft production reports. According to his statements to Allied interrogators, German aviation industry leaders initially dismissed intelligence about American production speeds as propaganda designed to demoralize German manufacturing efforts. The concept of applying automotive assembly line techniques to sophisticated military aircraft seemed to violate fundamental principles of aviation engineering. The revelation that American manufacturing methods could produce complex military equipment at unprecedented speeds forced German military planners to reconsider basic assumptions about war economics and resource allocation. Traditional European military thinking emphasized quality over quantity, precision craftsmanship over mass production, and individual excellence over systematic efficiency. American achievements at facilities like Willow Run suggested that quantity and quality weren't mutually exclusive when supported by sufficient industrial organization. German submarine commanders operating in the Atlantic provided additional evidence of American industrial capacity through their observations of Allied shipping patterns. According to Kriegsmarine patrol reports preserved in German naval archives, U-boat commanders noted increasing numbers of American cargo vessels carrying aircraft and equipment to European theaters. The volume of material being transported suggested production capabilities far beyond what German intelligence had previously estimated. Admiral Karl Dönitz, commanding German submarine operations, expressed growing concern about Allied shipping capacity in classified communications with naval headquarters. According to captured German naval documents, Dönitz noted that German submarine forces were sinking Allied vessels faster than traditional shipbuilding methods should have allowed replacement, yet Allied shipping capacity continued expanding rather than contracting. This suggested industrial techniques that German military planners hadn't fully understood. The intelligence challenge facing German military analysts was compounded by the speed of American industrial innovation throughout the war period. Facilities like Willow Run weren't simply scaling up existing production methods, but continuously developing new manufacturing techniques that improve both speed and quality simultaneously. According to Ford production records, the company's engineering teams implemented hundreds of process improvements during 1943 and 1944 that increased efficiency while maintaining aircraft quality standards. German technical intelligence specialists studying captured American aircraft components found evidence of manufacturing precision that challenged their assumptions about mass production limitations. According to German technical analysis reports, components from American aircraft displayed machining tolerances and metallurgical quality that traditional European manufacturing methods achieved only through time-intensive individual attention. The fact that American factories were producing such components at high volume suggested automated precision that German industry hadn't developed. The strategic implications of American industrial capacity were becoming apparent to German military leadership through various intelligence channels throughout 1944. Field reports from combat commanders, technical analysis of captured equipment, and economic intelligence about Allied production capabilities all pointed to war manufacturing American advantages that were expanding rather than stabilizing. This suggested that time was working against German strategic interests in ways that traditional military planning hadn't anticipated. General Franz Halder, former chief of the German General Staff, provided post-war analysis of German intelligence failures regarding Allied industrial capacity. According to his testimony to Allied interrogators, German military planning had been based on European precedents for industrial mobilization that proved inadequate for understanding American manufacturing capabilities. The speed and scale of American industrial conversion exceeded German analytical frameworks for assessing enemy production potential. The cumulative weight of evidence about American industrial achievements was forcing German military leaders to confront strategic realities that challenged fundamental assumptions about the war's trajectory. Intelligence reports about facilities like Willow Run suggested that American industrial capacity was expanding faster than German military forces could effectively counter through combat operations. This mathematical reality implied strategic consequences that traditional military thinking struggled to address. German economic analysts studying Allied war production capabilities provided assessments that reinforce military intelligence about American industrial advantages. According to German economic intelligence reports preserved in captured documents, American manufacturing capacity appeared to be expanding at rates that defied European precedents for wartime industrial mobilization. The sustained growth of facilities like Willow Run suggested organizational capabilities that German industry hadn't achieved. The psychological impact of these revelations on German military morale became apparent through various intelligence sources during late 1944. According to prisoner interrogation reports, captured German military personnel expressed disbelief when informed about American production statistics, often insisting that such figures represented propaganda rather than actual achievement had in accepting dissonance reflected. This cognitive the difficulty German military culture evidence that challenged fundamental production statistics assumptions about industrial limitations. The final from Willow Run represented achievements that German intelligence analysts found difficult to process within traditional frameworks for understanding manufacturing capacity. By war's end, according to Ford Company records, the facility had produced 8,865 B-24 heavy bombers during its operational period, representing more aircraft than many entire nations had manufactured throughout the conflict. The implications of such concentrated production capability challenged German strategic calculations about the sustainability of continued resistance. The legacy of these intelligence failures would influence German post-war analysis of American industrial capacity and organizational methods. According to testimony from captured German military leaders, the revelation of American manufacturing achievements like those at Willow Run represented a fundamental miscalculation about Allied capabilities that contributed to strategic decisions throughout the war's later phases. The inability to accurately assess American industrial potential had strategic consequences that extended far beyond tactical considerations. The final production statistics emerging from Willow Run by war's end painted a picture that German intelligence services found impossible to reconcile with their understanding of industrial limitations. According to Ford Motor Company records, the facility had delivered 8,865 B-24 Liberators by the time the last bomber rolled off the assembly line on June 28, 1945. This represented approximately 70% of all B-24s produced by Ford across multiple facilities, with the company also manufacturing knockdown kits for an additional 1,893 aircraft assembled by other contractors in Fort Worth and Tulsa. The mathematical implications of these achievements created strategic problems that German military planners struggled to address through conventional tactical responses. Intelligence assessments preserved in captured Wehrmacht documents reveal that German analysts calculated they would need to destroy American bombers at rates exceeding 2 aircraft per day just to prevent Allied bomber strength from increasing, let alone reducing it to manageable levels. Willow Run alone was producing bombers faster than the entire Luftwaffe could realistically engage them in combat. German technical intelligence specialists studying the broader implications of American mass production methods found evidence that the Willow Run model was being replicated across multiple industries and facilities. According to captured German industrial intelligence reports, similar production techniques were being applied to fighter aircraft manufacturing, naval vessel construction, and even small arms production throughout American war industry. This suggested that Willow Run represented not an isolated achievement, but a systematic transformation of American manufacturing capability. The psychological warfare implications of these production achievements extended far beyond simple material advantages. German military personnel confronting the reality of unlimited American industrial capacity faced morale challenges that traditional military leadership hadn't anticipated. According to prisoner interrogation transcripts, captured German aircrew members frequently expressed resignation about the mathematical impossibility of achieving victory against opponents with seemingly infinite material resources. Dr. Ferdinand Porsche, renowned German automotive engineer and founder of the company bearing his name, provided post-war testimony about German industrial reactions to intelligence reports about American manufacturing achievements. According to his statements to Allied investigators, German automotive and aviation industry leaders initially dismissed reports about facilities like Willow Run as technically impossible given their understanding of production engineering. The concept that complex aircraft could be manufactured using automotive assembly line principles violated fundamental assumptions about the relationship between product complexity and manufacturing speed. When the last B-24 Liberator rolled off Willow Run's assembly line on June 28, 1945, it marked the end of an industrial revolution that had redefined the mathematics of warfare itself. Charles Sorensen's impossible dream, sketched on hotel notepaper 4 years earlier, had produced 8,865 heavy bombers and shattered every assumption about what American industry could achieve. The German intelligence analysts, who had initially dismissed Ford's claims as propaganda, learned a harsh lesson about underestimating democratic industrial capacity. Willow Run proved that in modern warfare, victory belongs not to the nation with the finest craftsmen, but to the one that can transform complexity into simplicity, scarcity into abundance, and impossibility into inevitable reality. This story reminds us that throughout history, the greatest revolutions often begin with someone willing to reimagine what everyone else considers unchangeable.